And then we can move on to tree diagrams, and then we can sort of bring the section of statistics and probability to a close at some point. So I am going to go through this one very, very slowly, and I'm going to explain every single thing that I do. And I need you to ask as many questions as you need so that you understand it and nothing feels confusing or like you don't know where a number came from. Okay, so you need to use those voices of yours. When we're talking about Venn diagrams, the first thing is we want to make ourselves a little box, and we're going to draw our Venn diagram inside that box. And that box is our entire sample. So everyone in the story that we're going to talk about is going to fit inside this box. And then we're going to read through our story. It says, a grade 10 learner asks 200 vegans. Okay, so that means that my full total, so right at the end when I add everything up, I need to get 200. That is my full sample size, is 200. Remember, we can also write it like this. Okay. So they were asked if they like oat milk or almond milk in their coffee. She found that 72 people liked oat. She found that 110 people liked almond. And she found that 40 people liked both. Okay, so that's the important information that we need to take from this. So I'm going to have two circles that I care about. I have oat milk and I have almond milk. Oh, let me make that a little bit bigger to make it easier. Okay, so I've got my oat and I've got my almond. Yeah, small s. So let's start filling this in. We've got 72 people who liked oat. So that means that this circle over here, this full orange circle, those are all the people who like oat milk, right? And there are 72 of them. So I'm going to write 72 for the moment. And then it says we have 110 people who liked almond milk. So that's all of these people. And that's 110. But now if I then take that there are 40 who like both, the people who like both fit into this little middle category over there. So they're the ones who like both almond and oat. So we've got to do some playing around now. So we're going to put our 40 in the middle. So that's the people who like both. Okay. Now we know that this whole circle, so everyone who likes oat milk is 72 people. But at the moment it's 112 because we've got 72 and 40. So if we want to figure out the people who only like oat milk, we need to say 72 minus 40. And that's going to give us our nice answer here of 32. So these 32 people, they only like oat milk. And then we're going to do a very similar thing for our almonds. So our almond, we had 110 people, but we need to minus the 40 because all of these people in total needs to equal 110. So we have 110 minus 40, and that is going to give us 70. Okay, and that 70 is telling us the people who only like almond. Okay, before I do anything else, does anyone have any questions? Or does anything seem unclear or confusing? So now what we're going to do is we're going to add things up. So we have 32 people over here, 40 people over here, and 70 people over here. So 32 plus 40 plus 70. So what's that going to give us? That's going to give us 72 plus 70 is going to give us 142. Now, the problem is we know that our sample space is 200. What does that mean? Exactly. 200, which is our full sample space, minus the 142 that we've accounted for over here, that gives us 58 people. And those 58 people, they don't like either. So they like neither. They don't like oat or almond. And the fun thing with a Venn diagram is that if you add up your numbers at the end, so if we have our 32 plus 40 plus 70 plus 58, we should always get to our full sample size. So we always know if we are right. You're part of the 58. Fair enough. Okay, so now we have questions that are based on this Venn diagram. So the first question is, what is the probability that a person chosen at random will like oat or almond milk? So they can like oat milk or they can like almond milk. So how many people does that give us if they like oat or almond? So Beverly, that 40 is people who like oat and almond. But if we care about the people who like oat or almond, we've got 32 plus 40 plus 70. So these people, they only like oat. These people, they only like almond. And these people like oat and almond. So all of these people together like oat or almond milk. So that gives us 142 out of our full sample space of 200. And then we can simplify that down. But where's your 150 coming from? Okay. Okay. How many people did not like almond milk? Why are we including the 40? Because we care about anyone who likes oat or almond. Anyone who likes oat or almond. So we don't care only about that, but we care about anyone who likes oat or almond milk. And these 40 people, they do like oat or almond milk. Good. So how many people did not like almond milk in their coffee? So now we can't take anyone who likes anything to do with almond. So these people here, they both like almond. So we know these people don't like almond, and we know these people don't like almond. So we would say, who doesn't like almond milk in their coffee? 32 plus 58 out of 200. Making sense? Okay. What is the probability that a person chosen at random will not like either oat milk or almond milk? That one's nice and easy. We've already done that over here. So that's just going to be our 58 over 200. Exactly. Okay, what is the probability that a person chosen at random will not like oat milk? Oh my gosh. Oh yeah, no, that was right. Okay, I second guessed myself for a second. What is the probability that a person chosen at random will not like oat milk? Probability is an English test for sure, especially Venn diagrams. So if we care about the people who don't like oat milk, it will be these 70 people and these 58 people. So we'll say 70 plus 58. So 128 out of 200. It's okay. Oh yeah, no, we've just started. We've just started Venn diagrams. We can only get better from here. It just takes practice. It just takes practice, I promise. By the end of our session on Tuesday, you guys will all be pros at this. Okay, I'm going to zoom out in case anyone would like to take a screenshot. I'm going to give you a full human Earth minute to ask me questions if you need to ask questions. And then we're going to go into one where I'm going to let you try. Are you doing finance in school? I hope you're finding it nice and easy after we did it. Oh, I'm giving you answers. Hope you didn't see. Yesterday there was a fight. A female teacher got slapped. Yo. Scandalous. Okay. Your first mission, everyone, is to try and make this Venn diagram. So I've helped you with a little bit. I've drawn your box for you. I've drawn your two circles for you. You've got cats and you've got dogs. There is important information here. There are 160 people that we sampled in total. 33 liked cats, 65 liked dogs, and 22 liked neither. But they haven't told us how many liked both. Good. Let the intersection equal X. Great start. Okay, I'm going to give you a couple of minutes to fill it out. Do your best. Try not to get confused with all the words that are floating around. And then we can talk through it. Oh, yeah, no, that's very true. Like your formula is perfectly right, and if we were writing it like that, 100%. I think it was just the wording of the way that it was asked. In fairness, they probably would have given you marks for both, because it can be ambiguous. But that formula is 100% correct. The probability questions can get a bit iffy with the way that things are worded. So, Boo, if we have to, the first goal here is to actually draw this as a Venn diagram. So they would have asked you here how many people like both cats and dogs. So if we want to know who likes both cats and dogs, we have to find X. But if they don't ask you that explicitly, then yes, even if they're asking you to just draw a Venn diagram, if there's an X involved, you have to just find it and know that that's what you have to do. Again, not super clear. Beverly, nice job. Is 2 more minutes enough to finish it up? If it's not, that's also fine. Just let me know. I don't want to rush you. I want you to all give it a try. So this question, I'm going to warn you, is Yanda, you're going to hate this question. This is a clear example of a question that is ambiguous. And like rudely ambiguous. Ambiguous. So I generally, yes, I 100% would agree with the thought pattern that you've used there. It's not right for this one, but in a normal situation, absolutely. Okay, let me talk you through. So we have 160 people in total. Yeah, that's exactly what would happen. Okay, they've told us 33 people like cats, 65 people liked dogs, and 22 people liked neither. And we didn't know how many people liked cats and dogs. So in order to figure out who liked cats and dogs, we need to add everything up. So we say 33 plus X plus 65 plus 22 needs to equal 160. So we'll get to, let me just zoom out a little bit. Here we go. So we get to the point where we'll have X is equal to 40. I know. Because they didn't tell us. I know it was a horrible question. In fairness, I actually think it should have said 33 people liked cats only and 65 liked dogs only. That feels far more fair. Let me add that in so that we can have. I know it is an unfair question. I agree. So if we had gone the route with having everything minusing X, we would have landed up in a bit of a negative number situation. Okay, next one. Yanda's going to kill me again. Determine the probability of randomly picking a person that likes cats or dogs. Let me add in here. I'll just keep on adding things to make it more specific, to make them less infuriating. So determine the probability of randomly picking a person like that likes cats or dogs, but not both. Pop those numbers in the chat for me. No, I know, Yanda. So if they like cats or dogs, but not both, we've got these people, they like cats. These people, they like dogs, but these people like both, and these people like neither. So if I'm wanting to get to this answer, I would say 33 plus 65 out of my total of 160. So 98 out of 160. Yeah. Okay. Nice, easy one. Determine the probability of randomly picking a person that likes cats but doesn't like dogs. So a person that likes cats but doesn't like dogs. So if they like cats, but they don't like dogs, let's have a look. These people, they like cats. These people, they like cats, but they also like dogs, and they can't like dogs, so we can't include them. These people like dogs, so we can't include them. And these people don't like cats, so we can't include them. So the only people we can include are 33 people out of 160. Yeah, so Beverly, it's the way that the question was written. It was rude, but no, this is just going to be our 40, and that's just going to be 33, and that's just going to be 65. But I know it's an ugly question, if that helps. Okay, D, determine the probability of randomly picking a person that doesn't like cats. Hi. Randomly picking a person that doesn't like cats. So let's go through our little Venn diagram. These people like cats, so we can't include them. These people also like cats, so we can't include them. These people, they don't like cats, so we can include them. And these people don't like cats, so we can include them. So we've got 65 plus 22. So 87 out of 160. See, we're getting better. Zoom out so you've got the whole question. Okay. Okay. Now, this one is not an only situation. Okay. So when we start breaking up this, we've got 160 people who left Cavendish. All right. And they were asked if they had gone to Woolworths or Pick and Pay while they'd been in the mall. 85 people had been to Pick and Pay. It doesn't say Pick and Pay only. So it's just people in general who have been to Pick and Pay. This is 62 people who have been to Woolworths as a whole. So it's going to include the people who've been to both. And then we have 136 of the people had been to at least one of the stores. X people had been to both. Record this into a Venn diagram. So now we need to make our box. We need to draw our two circles. And we need to try and put all of this information into our Venn diagram. So it's a good question. Okay, if I have 136 people who have been to at least one of the stores, and I have 160 people that I have surveyed in total, that means I'm going to have 160 minus 136, which is going to give me 24 people who went to neither. I never said you were wrong. Oh, yeah, no, I think I have a plan that's going to help you with your ands and ors. I think I'm going to be able to like fix your and or situation with this question. I feel hopeful. Good. I'm liking that for eggs. I'm going to give you a couple more minutes. Okay, so we need to figure out what x is, right? We know that everyone in these two circles, that has to equal our 136. So we can say, okay, cool, 85 minus x plus 62 minus x needs to equal 136. So that gives us 147 minus x, which is equal to 136. So x is equal to 11. So then we know, okay, x is 11. So 85 minus 11 is going to be 74. 62 minus 11 is going to be 51. And then we've got our 24 chilling over there. Okay. So, Uyanda. What is, it doesn't have to just be to Uyanda, it can be to anyone. What is the probability that someone went to Pick and Pay? Good. So Tidimalo, I didn't say only Pick and Pay. So the probability that someone went to Pick and Pay is this whole circle. This whole circle is people who went to Pick and Pay. Because I didn't say Pick and Pay only. So in total, I have 85 people who went to Pick and Pay. Okay. What is my probability that people went to Woolworths? Oh, my Desdemonia. Don't worry, it's being recorded. Good. Probability of people going to Woolworths is 62. Oh, I should say, sorry. I can't just say 85. Gosh, needs to be a fraction. 85 out of 160. And the probability of people going to Woolworths is 62 out of 160. Okay, cool. I'm happy so far. What is the probability of people who went to Pick and Pay and to Woolworths? So that means they went to both stores. Good. That's just 11. That's just this dude over here, because they're the only ones who went to both. So that's going to be 11 out of 160. Okay. So when we say or, I'm going to write that formula for you quickly here. The probability of Pick and Pay or Woolies is the probability of one plus the probability of the other minus the probability of the one and the other. Right? So the probability of Pick and Pay is 85 out of 160. The probability of Woolworths is 62 out of 160, minus the probability of the and, which was 11 out of 160. What answer do you get? Because the number is floating somewhere on the board. Good. 136. Okay. If we didn't use the formula, if we were just saying who went to Pick and Pay or to Woolworths, right? These people went to Pick and Pay so that we can count them, 74. These people went to Pick and Pay and Woolworths. So they went to one of the stores so we can count them. These people went to Woolworths so we can count them. And that gives us 136. So Oyanda, when you're doing your or, you can absolutely add all three of those. If you're doing it this way, the reason we're minusing this and situation is because we're not just looking at the 74, we're looking at the probability of the whole of Pick and Pay and the probability of the whole of Woolworths. And so we have to minus that. Otherwise, we're including this 11 twice, and we can only include it once. And that's why we're subtracting it, so that we're not double counting it. Does that make a bit more sense? Do you hate it less? Good. Okay. Okay, so how many people, and they haven't asked probability, they've just asked people, how many people went to Pick and Pay, but not to Woolworths? Good. Good. 74 people. What is the probability that a person selected at random went to only one of the stores? So we look at our circles. We're looking for people who went to only one of the stores. So these people, they went to only one. These people, they didn't. These people went to only one. These people, they didn't. So 74 plus 51 is going to give us 125 out of my full sample size, which is 160. What is the probability that a person selected at random went to one of the stores? This is a classic rude English question because these two questions are different. So what's the probability that a person went to one of the stores? We have 136 out of 160. And the key difference between these two questions was that this one said only, and the other one did not. Okay, let me zoom out. Okay, if you have any questions, please ask. And then I'm going to get the next question up on the board. Okay. This one, you don't have to draw your Venn diagram. Your Venn diagram has been given to you. You just need to answer these 4 questions for me. Yep. Let me try. And I'll just say over here that there are 224 members. So that's my sample space. and D. Okay, so I'll put C over here. So let's have a look. Find the probability that the member only used the gym. So there's these people over here. Those are the only people who only use the gym. The others all used something else. And because they said only, we can only include them. So we're going to have 21 out of 224. Okay. Find the probability that the member used the gym. So that's everyone who used the gym. So that's going to be 21 plus, that's this one, plus 22, plus 32, plus 23, which gives us 98 out of 224. Happy so far? Feeling less scary than originally? Good. Nice. Yay, so nearly, that's great. Okay. What is the probability that the member did not use the gym at all? So that would be these people, because they didn't use the gym. They didn't use the gym. They didn't use the gym. But who else? These 36 also didn't use the gym. So I'm going to include all of those numbers. So I have 23 plus 38 plus 29 plus 36, which gives me 126 out of 224. What's the probability that the member didn't use any facilities? That's just going to be these people over here. So that's just our 36 out of 224. How are we doing in these 4 questions? What are we on? Are we on 0 out of 4, 1 out of 4, 2 out of 4, 3 out of 4, 4 out of 4? Let me know. We've got 2 more questions with this one. We've got E and F. 4 out of 4. Yes. Look at that. Okay. I'm going to write the next 2 up here so that you can see the Venn diagram. So this is E. The member used the gym and the pool but not the sauna. And F yeah. You're going to have to think carefully about F. Hmm. I'm curious to see some more answers for E. Pop your answers for E in the chat. And I haven't seen an answer I like for F yet. Mm-mm. Okay, so let's look at E. E says that they want the probability that the member used the gym and the pool, but not the sauna. Gym and the pool, not gym or the pool, gym and the pool. I'm just going to leave that there for the moment. And this one says, given we know it's someone who used the gym, find the probability that they also used the pool and sauna. Okay. Are you ready to be taken out of your misery? Misery, not mystery, I suppose, but of both. Okay. Because they said the member used the gym and the pool, but not the sauna, these people only used the gym These people only use the pool. So those are people who use the gym or the pool. These people use the gym and the pool, but these people also use the sauna. So the only people who use the gym and the pool are those 22 out of my 224. Now, F. F says, given we know it's someone who used the gym, that means our denominator is people who use the gym. So our denominator is going to be 98. What is the probability that they also use the pool and sauna? So then we're going to look at the people who use the pool and the sauna, which is 32 out of 98. Okay, we're going to end off our lesson. If you want to take a screenshot, please feel free. We're going to end off our lesson on trying to draw out a Venn diagram. We won't answer any of the questions. We won't have time. But my goal is I want us to at least have the drawing of the Venn diagram so that we've got it ready for our lesson on Tuesday. Okay. There are 24 dogs in total. That's our sample space. We have got black dogs. We have got dogs with short tails. And then we have got dogs with long hair. Those are our 3 circles. Be very careful with the way that these have been worded. Give it your best go. And then we can fill it in. Let's see if you can get this Venn diagram. Remember, when you add them all up at the end, you need to get 24. And if you don't get 24, something has gone wrong. Okay, maybe a few more minutes. Do your best. See if you can figure it out. It'll be very exciting if you're right, I promise. boo. We're not talking about titration practicals. We're talking about Venn diagrams. Okay. The easiest way to go about Venn diagrams is to see if you can work from the middle and work your way out. You don't have to do it that way, but that is the easiest way. So if we can find one that has everything, that's generally the one that we want to look at. So this over here, this says that there's only one dog that is black with a short tail and long hair. So we know that we've got one right in the middle because that's all of the different categories. So now we've done this one. Cool. Then we can kind of start moving our way out a little bit. We've got two of the dogs. Oh, let me get a different color. Two of the dogs are black with short tails and do not have long hair. So they are black and they have short tails, but they don't have long hair. So I've got a 2 sitting over there. How are we doing so far? Are we getting the same numbers? I'm hoping so. You're just going to throw numbers at me. Okay, then we have two of the dogs have short tails and long hair, but are not black. So they have short tails and they have long hair, but they are not black. So now I'll know that that one's also 2. Okay. Next, they've said we have 5 dogs that are black with long hair, but they don't say only. So that means that this whole section here needs to be 5, which means this is going to be 4, because 4 plus 1 is going to give me my 5. So that's dealing with that one. Okay. Then we can start moving up a little bit. We've got 12 of the dogs are black. So that means in total, this needs to be 12. So I've got 4 plus 1, which is 5, plus 2, which is 7. So this is going to have to be 5 so that I land up with 12 in total for my black dogs. Dealt with that. Then we have 6 of the dogs have short tails. So 2 plus 2 plus 1, which means that has to be a 1 because I have 6 that have short tails. And then we have 15 of the dogs have long hair. So we've got this needs to add up to 15. So we're going to have 8 dogs that have long hair. Who managed to get these right? Let me know. Yes, Uya, your hand is up. How exciting. Do you have a question? Okay, what do we have to do now? What do we have to do for the last one? Oh, were you just saying you got the numbers right? Sorry, Uya, my bad. What do we have to do to sort of make sure that everything is final before we can end this one off? We've got to add everything to make sure that our numbers exactly. Double check to see where we're at. Oh, gosh, just writing all over the place. Okay. So we have these 12, right, for the black ones, plus 8, which gives us 20, plus 2, which gives us 22, plus 1, which gives me 23. So that's problematic. That doesn't give me 24. What do I need to do then? We have 1 that's outside. And that, my lovely 11s, is the end of our first lesson of Venn diagrams.